5.5 Trigonometric identities. An identity is a mathematical statement that is true for all values of the given variables. It must state any restrictions on the variables. Examples of simple identities are x plus negative x equals 0, x to the power of 0 is 1. Please note, you always use left side, right side check to see if the left side of an identity is equal to a right side of the identity. We use primary trig ratios, so if an identity is given to you, you ask to prove it, and you're given secondary trig ratios, so you can convert them to their primary trig ratios and then simplify. Use sine and cosine ratios. Look for ways to simplify your given expressions by doing algebraic manipulations like factoring, expanding, using the Pythagorean theorem, finding common denominators and adding fractions, and so on and so forth. The three identities we first are looking at are reciprocal identities. We already know them. Cosecant theta is 1 over sine theta, secant theta is 1 over cos theta, and cot theta is 1 over tan theta. The next identity we have to look at is this one here, the quotient identities, which is tan theta is sine theta over cos theta, and cot theta is cos theta over sine theta. We're going to do a proof for this identity. So we're going to start with a right angle triangle. Let's say this angle here is theta, this is y, this is x, the hypotenuse is r, and the left side of our identity is tan theta. Okay, we have to prove that it's equal to sine theta over cos theta. Looking at this diagram, what are our values for sine theta, cos theta, and tan theta? Well, we have sine theta is y over r, cos theta is x over r, and tan theta is y over x. And so we can say that the left side is tan theta, which is y over x, right? And the right side of our expression here is sine theta divided by cos theta. So that would be y over r, which is sine theta, divided by x over r. And if we were to simplify this like fractions, this would be y over r times r over x. R would cancel out and we get y over x. So you have the left side is simplified as y over x. The right side is also simplified to y over x. So therefore our left side is equal to right side. And therefore we have proven that this holds true for all values of theta between 0 and 360 degrees, including those angles. So tan theta will always be equal to the ratio of the sine theta divided by the cos theta, and cot theta is a ratio of cos theta over sine theta. Next proof we're going to look at is prove that this identity is true. Sine squared theta plus cos squared theta equals to 1. Again, we're going to start with a right triangle. Let's say this angle here is theta, this is y, this is x, this is r. And the left side is sine squared theta plus cos squared theta. Looking at this diagram, our sine theta is y over r, cos theta is x over r. So our left side is y over r squared plus x over r squared. Simplifying, that is y squared over r squared plus x squared over r squared. Denominators are both r squared, so we can add them up as x squared plus y squared. And we know from the Pythagorean theorem that r squared, which is the square of the hypotenuse, is equal to the sum of x squared plus y squared. So we can rewrite this numerator as r squared. R squared divided by r squared is 1, which is our right side. So we have proven that that this is true. Sine squared theta plus cos squared theta equals 1. This identity is called a Pythagorean identity. It can be rearranged in this way, where you bring the cos squared to the right side. It will be sine squared theta is 1 minus cos squared theta, or bring the cos squared the sine squared to the right side and rewrite it as cos squared theta is 1 minus sine squared theta. So here we have a proof. Let's prove that this is equal to this. Prove that 1 plus sine theta plus 1 over 1 minus sine theta equals 2 secant squared theta. So let's take the left side of this identity. 1 over 1 plus sine theta plus 1 over 1 minus sine theta. Let's try to add them like we were adding fractions. We would find their common denominators. And then we would multiply them. This would multiply with 1 minus sine theta. And this would multiply with 1 plus sine theta. Just like you were adding fractions. Then you would have 1 times that is 1 minus sine theta. Plus 1 times that is 1 plus sine theta. In your numerator, you have sine theta minus sine theta. They cancel out. They add up to give you 0. So you have 2 divided by 1 plus sine theta times 1 minus sine theta. If you look at your denominator, it looks like it's in the form a plus b times a minus b, which can be written as a squared minus b squared. So that is something I'm going to do now. I'm going to rewrite the denominator as 1 squared minus sine squared theta, or that is 1 minus sine squared theta. Now, we already saw this identity in the beginning, right? Sine squared theta plus cos squared theta equals to 1, or sine squared theta is 1 minus cos squared theta, or cos squared theta is 1 minus sine squared theta. So that means in this case, 1 minus sine squared theta, this thing can be rewritten as cos squared theta. So this is 2 over cos squared theta. And cos squared theta is the reciprocal of secant squared theta. So this can be written as 2 secant squared theta. And that is our right side. So we have proved now that our left side equals to our right side. So always work with looking at the right side in mind and trying to get and arrive at that answer. Okay, so our next one is to prove that secant to the power 4 theta minus tan to the power 4 theta is 1 plus 2 tan squared theta. I'm going to write that on a new page so I have more room. Secant to the power 4 theta minus tan to the power 4 theta equals 1 plus 2 tan squared theta. So here I'm starting with the left side. Secant to the power of 4 theta minus tan to the power of 4 theta. I'm going to rewrite this as secant squared theta squared minus tan squared theta squared, so that I can see this as a difference of squares. Okay, difference of squares factors as a plus b times a minus b, right? So this can be factored as secant squared theta plus tan squared theta times secant squared theta minus tan squared theta. And I'm going to bring them down to the sine and cosine instead of secant and tan. So this will be 1 over cos squared plus sine squared theta over cos squared theta times 1 over cos squared theta minus sine squared theta over cos squared theta. And I'm going to add them like I would add fractions. And so then my denominator will be cos squared theta and 1 plus sine squared theta here times cos squared theta and 1 minus sine squared theta here. Now doing this, I noticed that this can be rewritten as cos squared theta from the trig identity that sine squared theta plus cos squared theta equals 1. So 1 plus sine squared theta divided by cos squared theta, this stays. And this can be written as cos squared theta divided by cos squared theta. This cancels out and I get 1. And now I have to kind of work my way with this to bring it to 1 plus 2 tan squared theta. So I'm going to take the numerator. So I have 1 plus sine squared theta divided by cos squared theta. I'm going to rewrite this one as sine squared theta plus cos squared theta, because I know that that is true, right? If they add these two, they add up to 1. So sine squared theta plus cos squared theta is what I'm rewriting 1 as, plus sine squared theta divided by cos squared theta. So now I have 2 sine squared theta plus cos squared theta divided by cos squared theta. I split them up as if I'm adding two fractions with cos squared theta. And so that's 2 sine squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta. I split them up. So that's 2 tan squared theta plus 1, or 1 plus 2 tan squared theta, which is my right side. Okay, so this comes with practice. You have to try sometimes several times to arrive at the answer, because you're trying to work through manipulating the expressions to kind of make them equal to the right side. So it's only something that you can develop by practicing the questions. So I'd like you to try the questions that have been assigned so that you can get more experience.